All right, so far we've seen interactive mode with our simulation for just visualizing our geometry, but this is what we'll do, well, what is typically used for interactive mode for the vast majority of the time, but you can also use it to visualize particles and the particle tracks. So we looked at different macros, and the macros has all the options. Let's go to run carbon, for instance. So it has certain particle options and beam shapes and other beam parameters like direction, energy, and you can also set verbosity options such as tracking verbosity. And so any of these commands you can also apply into a interactive session, as well as the beam on. So if we just go run beam on, and I might just maximize that so you can see the bottom text pop up. So run beam on, and let's just shoot one particle. And as you see, we've got this green track going where we got Z, so positive Z, negative Z here. So if we just put the verbosity on to see what it was doing, so track verbos, so track verbose 1, and let's just run that particle in. So I'll just go arrow up, shoot it, and so this time see showed Geant4, and the starting position was 0, 0, 0, as you would expect as a default, so all zeros, but with a kinetic energy of 1, so x, y, z, then energy there of 1, and it was going in the the negative z direction, so positive z, so again this is z not y because of the shift, so started at positive z and went negative z. And as I was saying, as you can change the particles, so if we went to GPS and particle, and let's say if we want to shoot a photon, say gamma, and just shoot that again, and this time you see a more interesting track with the particle actually interacting. So if we looked at the track, you'll see, the gamma 1MeV undergoes Compton interactions, and any electrons produced. Let's make this a bit bigger. So just try to look for some electrons, but I guess they're very low energy. Okay, they're tiny energy, so I wanted to point out the colors of electrons, but I'll do that soon. But if you zoom in, hopefully might be hard to see, but if you zoom into a track, you'll see these yellow dots or circles along the track, and these yellow circles, points, they represent the real tiny. So these yellow points represent steps in the particle. So every time you see a new step, one of these yellow points will occur. So here our primary photon started here, and then at 0, 0, minus 20.2 in the Z, it had a Compton interaction, so Compton here, and that's represented by that yellow point, so that just means there was a step at that point, and maybe this will, if there was a high energy electron, we could actually see the track. Actually, let's just see if we can zoom in and let's okay. Let's just change the particle type. So so let's go GPS particle type, and let's go E- for an electron, and let's just zoom out here. Actually, let's see if I can remember the actual command. Set viewer, set angle, set is, okay. I was going to be fancy and snap to the default, but what was I doing? I was changing the particle type to electron, or did I do that? Yep, so I've got an electron. So let's shoot the beam. So run beam on 1. And this should shoot an electron of 1 MeV. And because the energy is quite low for our meter cubed world, it's not the easiest thing to zoom in. So if you squint very closely, you'll see this red track of the electron, and again you see these yellow points representing the steps of the particle, and you'll notice that it's red instead of what we saw for the photon and the Geant4. So the default of Geant4 is when it's visualizing the particles, is greens represent neutral particles, so with no charge. So that'll be your Geant4s, your photons, neutrons, and particles with a negative charge will be represented with red, and then positive charge will be represented with blue, so protons or any other ions. And let's set the energy. Let's just shoot a proton now. And again, just use any of these options. So let's do GPS, then energy, and then let's just make sure energy mono, and let's give it a 100 MeV, and let's zoom out, and actually let's let's shoot a electron now that we've got 100 MeV electron, and hopefully we're not breaking it too badly. So I didn't specify the units. I didn't. Okay, so it's just defaulting to EV or MEV. So change it to kV. So let's just shoot that electron again. So now you see a bit more of an interesting track. Terrible angle I've got it set to. Let's move. So red tracks, your neutral photons, and let's just finally change it to proton. So particle and proton, and let's just shoot that proton beam. So here you see we've got our blue track. So because it's a positive charged particle, it's being represented as a blue track by default. So just one thing should point out, when you're running in interactive mode and you set all these options, none of these options will actually carry over to your next session. So if you wanted to like shoot the same thing like you were shooting electron time after time, you couldn't just go run beam on and it would shoot the same thing, and you can't even do arrow up. So I was instinctively trying to just go arrow up and shoot the beam like the last command. So if I just go shoot beam on 1, then you see, like our first time, we get this green line representing our neutral Geant4. And if you wanted to set the verbosity again, you would have to go tracking verbose 1. So this gets pretty annoying if you keep wanting to apply the same option. So if you just go into your main, so just as a bit of a reminder, remember the main will define what happens if you just execute the program by itself. So the main tells it that so when you execute the program by just itself, the main will tell it to just execute the macro init_viz.mac, and then once in there, you see that it actually, all this macro pretty much does is then execute the viz.mac macro. So let's say you had some options that you were running time after time, then you just add them to your viz.mac in this case. So let's say you always wanted the tracking verbose set to 1, so you just go tracking verbose 1. And if you wanted to define a beam, I've just pasted this stuff here already, but let's say you wanted to shoot a beam and position there, and let's give it a direction. Let's just copy from our macro, so just copy that direction, paste that there, and let's shoot in the positive y direction. So, positive y, get there. So, as I said at the start of this video, often interactive mode's just used for visualizing geometry, but often it's quite handy to verify what you're shooting visually. Of course, there's always the tracking verbose 1, just checking what your particles are, but for a simple representation of what your particles are doing, often it's helpful to just to visualize the particles. So now that I've added these lines to the viz.mac, so I've got the tracking verbose set to 1, and I've given it these options. So if I run a beam, it should start at this position, so it wouldn't actually change from its default, but its direction would now go in the y direction and the shape would be different. So if I just go run beam on 100, and it should be shooting Geant4. So we don't see anything at this angle, but once we go here and give it a look, it's, if we look at what we were actually inputting, so we inputted a beam shape of a square, and we gave it half x, half z of 5 centimeters and shot in the positive y direction and starting from 0, 0, 0. But here we see that we're actually getting like a line source going the positive y direction. So this is, showing how the interactive mode can be quite useful for like debugging your beam, because you're seeing instantly what it's doing. So with the general particle source of the GPS, it's set up to pretty much always shoot in the Z direction. So if you have your beam direction in anything other than the Y direction, if you're shooting your beam in any direction other than the Z direction, and you define some beam parameters like its shape, it will be applying that to the Z plane. So be applying this like the shape along the Z. So you have to, if you ever want to shoot in a non-Z direction, then you have to rotate the beam profile. So I've handily got it defined here already. So I'll just copy it into the the interactive terminal, and I didn't actually want to shoot in the Y plane. So let's just close this session, and let's just, I didn't want that. Whoops. Oh well. So we'll close that, and we'll just reopen it and wait for that again. And so let's just run beam on once more, do 100. So again, you see that, and that was done intentionally just to show you how weird the GPS can be when you're not shooting in the Z direction. So, you would think half Z would be half your Z shape if you're shooting the Y, but due to the way GPS works, you have to actually say half Y. Sorry, got confused with what I was writing and typing. So we had it set to Z, and that gives this distribution, even though where we flipped it. But what we need to do is give it shapes that it expects in the Z, as in shooting it as if we were shooting in the Z, and then we rotate that whole plane into the different axes. So if you're ever doing a simulation with GPS, then it's always, I didn't do run beamer. So if you're ever doing a simulation with GPS, it's always easier to shoot in the Z plane, because you have to be very careful of how you treat your beam distribution. So anything non-standard gets a bit complicated, but now you see, once we've applied this rotation matrix here, then now the beam's actually shooting a square distribution. So that's just showing the main ways you can use use Geant4 in interactive mode to shoot particles, and you can verify what you're shooting quickly by just visualizing what your beam's actually doing, and that's mostly it.